Hi, welcome once again. So this is the next video in the series of videos which we are publishing related to the kind of questions which are asked in the interview of Bhabha Atomic Research Center. As I've already told you earlier that the interview of BARC is one of the best interviews you will ever face in your life, because the length of the interview is long and the requirements are different. They will ask you questions starting from very basic, and then they will keep on increasing the difficulty level of the questions in the interview. So first they will ask you very basic question, and then they will keep on checking your thinking pattern. They do not check your knowledge base. Many students get confused that they are to prepare in depth or something like that. Actually they check your thinking pattern. They will give you very basic questions and slowly they will force you to think, and they will give you sufficient time to think also. So when you hear that okay, BARC interview is very long and it takes more than 1 hour for the interviews, the reason for that is like they give you a lot of time to think and give them answer, and you should not be in hurry to give the answer. So the basic questions you can solve, but when the real thinking is involved, where convergent divergent thinking is required, creative answer is required, that actually gets you selected. Not a basic question, answer of basic question does not get you selected or rejected for that matter. If some question is asked to you and basic question you are not answering correctly because of you don't remember the formula or something, it does not matter, they are not after that. But when a real good concept is asked where you have to think, that time the credit is given. So the best way to go for such interviews is like you should ask yourself, when you are studying some subject, you should ask yourself how this has happened, why this has happened, how it will come, what is the reason for that. So these are the real things which you should ask yourself, and accordingly you should proceed forward. Now in this series we are discussing with you the actual questions which were asked to our students in previous years in BARC. As you know, YourPedia is one of the largest, in fact it is the largest platform which is mentoring students for online interviews and offline interviews, and we keep on mentoring hundreds and thousands of students, and we get the feedback also from these students. So on the basis of that we are discussing this particular thing with you. And this question, again I have brought this question from strength of material subject. So as you know, when you go for interview in BARC, they ask you some favorite subjects, and in each branch you have couple of core subjects. Strength of material is one of the core subject for civil engineers and mechanical engineers. This is the starting of design section for both these branches. If you say strength of material is your favorite subject, then he will start asking you basic questions from that first. So I am here writing the questions which were told to me by student, that these were the questions asked, and I found this as a good question. And answers I am not giving what answer student must have given, I am not discussing that. I am giving you what answer could have been there, what you should have said for this question. And you will find that the question starts with very basic and then keep on entering in depth into that. So that is how it goes. Let's start it now. So the student must have said my favorite subject is strength of material. Then he asked you, what do you understand by shear force, and why is this called shear? So sir, shear force is also called tangential force. If I give you three-dimensional view of a body, then this is called shear force, F is called shear force, because as you can see the force is tangential to the cross section area of the body. Let us say this side is A, this side is B. When the force is applied, A goes to A dash and B goes to B dash, and there is a shearing of one plane with respect to another. So the plane AB, suppose this end is A, this end is B. So plane AB has gone to A dash B dash. So the top layer there is a shearing of top layer with respect to bottom layer. So we are assuming that bottom layer is fixed and the top layer has gone, it has basically tangential flow, or it has sheared with respect to bottom layer. Something like pack of cards, जो ताश के पत्ते होते हैं, अगर तुम फोर्स लगाओगे टेंशियल फोर्स तो वो आपके स्लाइड कर जाएंगे. So in this way, this force, tangential force to the cross section area is called shear force. Now what happens to the bending is, suppose there is a beam के case में, if I am giving you a beam subjected to some kind of load, now this load is also the shear load for the beam. Why? Because this force is tangential to the cross section area of the beam at that particular point. Hence this particular force is called shear force. So why is this called shear force? What do you understand by shear force? This is the first question you should know. Then he says, what do you understand by bending moment? Bending moment. And every shear force producing the moment effect also. When a force leads to bending of particular body, and the force produces the moment and it leads to bending moment. Whenever you apply a force, it has a rotating impact also. That force can become moment. What is moment? Force into distance is called moment. So is every moment bending moment? When a moment is called a bending moment. What is the difference between moment and bending moment? Sir, if I give you a door, and the door is sliding across the hinge point, suppose I apply a force and this force is applied at distance r from the hinge of this door, then this force into perpendicular distance is called moment. Now this moment is not going to bend the door, it is going to rotate the this particular door. So force into distance is moment. Every moment is not a bending moment. The question was asked, is moment and bending moment, is there any difference? Yes sir. When I apply a force on a body, and if the body can rotate about one particular axis, then the body will rotate. So force into that perpendicular distance is called moment. Like when you open the door, torque is also similar to that. So that moment or torque is the same thing, right? Now bending moment is something when you apply a force and the body bends. What is the example? Again, let me give you a body beam and a force is applied. So let me choose different color here. So if you see, this body can bend like this. When you apply the force, this body can bend like this. So what is this? This is the deflection. I can say this deflection is, let us say, y, that is a deflection. So I applied a force and this force is leading to some kind of bending effect, and now this force, obviously if this is the force, we have reactions also, let us say Ra and Rb, and we make a bending moment diagram. In bending moment diagram we show at each section what is the bending moment. Moment is force into distance. Can you tell me what is the bending moment at this point? Yes sir, Ra into x. Okay, Ra into x is the bending moment. So what is the bending moment at section x? Sir, Ra into x. I am not considering sign convention or something, though it is positive. So Ra into x is the bending moment. Now this bending moment, this moment is called bending because the impact or the effect is bending of the beam. So that is why it is called bending moment. Whenever you are explaining, whenever you are giving answer in BARC interview, try to explain the things. Many students will not even bother what is the difference between moment, torque and bending moment and couple. They will not even bother. There is a difference between couple. Couple means two forces equal and opposite separated by some distance. Moment is force into distance. Torque can be applied directly. It can be a couple. Torque, it can be force into distance. So many students are not even bothered to tell the difference between these bending moment and all, but you should, you should explain that. Why do you draw shear force diagram? We draw shear force diagram to find out shear force at each section. At each section I want to find out shear force. Okay, good. And if I draw shear force diagram to find bending moment diagram BMD thereof, and I want to find out what is the BMD. So there is a load diagram, then you draw the shear force diagram. At each section I want to find out what is the shear force, and then I want to find out what is the bending moment at each section. That is another reason why I draw shear force diagram. Why do you draw bending moment diagram? To find bending moment at each section. And as you know, bending moment we write as M at section X at each section. So I want to find out what is the bending moment at each section. That is what I want to find out. What is the bending moment at each section? That is something which I want to find out. I want to find out bending moment acting at each section. Why do you want to find out bending moment acting at each section? Let me give you bending equation. M over I is equal to sigma over y is equal to E over R. Now, if I want to find out what is the bending stress acting at particular section X, what is the bending stress acting at particular section X? This is the equation by which I can find out. Now suppose I want to find out the maximum bending stress. Why do I want to find out maximum bending stress? Because maximum bending stress should not exceed the yield strength of the material, or else beam will fail. So if I want to find out that, for what load, up to what load beam may fail or may not fail, I need to find out what is the maximum bending stress induced. To find out maximum bending stress induced, I need to find out what is the maximum bending moment. Now, how do I know what is the maximum bending moment? I need to draw a beam, and on that beam I need to find out the bending moment diagram. In the bending moment diagram you will get where you get maximum bending moment, and accordingly you will find it out. So wherever Mx is maximum, you can find out, because I depends upon transverse section. So moment of inertia depends upon the transverse section, and for particular section you can find out the value of I, and y we can take maximum, and accordingly we find out what is the maximum bending stress. And if I know maximum bending stress, I can find out whether it is less than or not. So as you know, it should be less than the yield strength of that particular material. And then there is a concept of factor of safety. Factor of safety is nothing but maximum bending yield strength. So as you know, there is a concept of factor of safety, that is nothing but yield strength of the material over maximum stress which can be induced, and depending upon what theory of failure you are using, you can calculate the values of factor of safety. That is how you do it. Okay, now that is, so far it is this. Next question comes, how can you calculate shear force from bending moment diagram? Now let me tell you, shear force is nothing but it is the slope of bending moment diagram. Shear force is nothing but it is the slope of BMD. If I give you the slope of BMD, if you give me the slope of BMD, I can tell you what is the shear force at that section. Okay, let me give you. If I give you this as, let us say, the BMD. This is the BMD. Let us say this value is 10 units. This is 2 units. This is 2 units. This is 10 units. This is Newton meter and this is meter. Then as you know, the slope of this I am saying is BMD. Sir, where do you get such BMD? Okay, let me give you a cantilever subjected to some particular load at the free end. This length is L. Draw the BMD of this. L is 2 meter. So you will get BMD something like this. What is the slope of this? The slope of this is nothing but 10 over 2. 10 over 2, that is 5 Newton. Okay. So that means the shear force across each section is 5 Newton. I am applying 5 Newton here and the length is 2 meter. Tell me what will the bending moment produced at the fixed end of cantilever. Resisting moment produced will be 10 Newton meter. Okay, so that means slope of BMD gives me shear force. How do you calculate bending moment from SFD? Okay, let's go reverse of this. dmx is equal to fx dx. Can I write like this and integrate it? So that means from A to B if I go, mb minus ma is equal to fx dx A to B. Now what is the meaning of that? If you take the area of SFD between any two sections, that gives you difference of bending moment between these two sections. Listen this carefully. If you give me SFD, if you give me shear force diagram, then this particular thing is nothing but this is the area of shear force diagram between two sections. And if I integrate it from A to B, that total area of SFD between two sections give me the difference of bending moment between these two sections. The area of shear force diagram between two sections give you the difference of bending moment between these two sections. That is how you calculate this particular thing, and that is the meaning of this. So the difference of bending moment between two sections is equal to the area of shear force diagram between these two sections. Now suppose I give you, this is the SFD. Let us say this is SFD, 2 meter, let us say this is 5, 2 meter and this is 5. Okay, so what is the area? Let us say this end is A and this end is B end. This end is A, this end is B. SFD will be like this because shear force is not changing. Can you tell me what is the total area of shear force diagram between A and B? That is 10 Newton meter. Now this 10 Newton meter is MA minus MB, and what is the bending moment at B? That is 0. So what is the bending moment at A? That comes out to be 10. So from these two we can calculate what is the area between these two. Now what is the slope of SFD? Okay, slope of F is nothing but load intensity. This is nothing but load intensity. I am just telling you the kind of questions which are asked, and you know, question may look like simple, but the way you explain, that is very, very important. You need to give answers and explanation something the way I am telling you. Now you are sitting on the chair, find the normal reaction on these legs. Now this is the time when a student is sitting on the chair, and now the next question comes, the chair on which you are sitting, tell me what will be the reaction on the legs of the chair. Will it be all same? There are 4 legs. What is your weight? Is W. What is your weight? Is W. Now reaction on each will be equal to W by 4. That will be W by 4. But it may not be equal to W by 4 because your legs are touching. Your legs are touching the ground. They are not in air. If you are sitting with your folded legs on the chair, and if your center of gravity is on the center of chair, then this answer is correct. But since you are not sitting with your legs on the chair, your legs are touching the ground, and if the legs are touching ground, there will be some normal reaction. So let us say reaction on legs is this. Reaction on legs. He is not interested in your answer, as I told you. He is interested in your approach. Let us say reaction on legs is RL. Then what is the reaction each? Will be WL, W minus R on L by 4. Let us say reactions acting on legs is this. Then the total reaction on each of the leg of the chair will be weight of the body minus reactions acting on the legs divided by 4. And that is if entire weight is concentrated or entire weight is on the center of the chair. But if it is not on the center of the chair, it is not assumed on the center of chair, then we have to calculate reaction on each leg will be different. So in which case the reaction on each leg will be different, same. Answer is if entire load can be assumed to be located in at some particular center, then you can say the reaction is same. But if it is not there, it is not concentrated on the center, then entire the reactions will be different. This is how it is to be done. Now let us go next question, which was really good question. Assuming chair as beam with two simple supports on two legs, draw its SFD and BMD. Now that is really good question. Assuming that chair as a beam with two simple supports, simply supported beam on two legs, draw its SFD and BMD, you sitting on the chair. Now normally what I found is students tend to make this mistake. What they do is, what they would have done is, let us say this end is A, this end is B, and the body of weight W is concentrated at the center. Let us say this is the width of the chair, L is the width of the chair, and then I assume it to be at the center. This is W by 2, this is W by 2, and you know how to draw the SFD and BMD for this, that everybody knows. But there is a small, there is a small mistake in this. You are not actually sitting like this. You are not a point load. If there is a chair, like this, then your body entire weight will be distributed weight. This is a UDL case, not point load. So load intensity is W per unit length. W per unit length. Let us say you are occupying X width of the chair. Let's say you are occupying the width of the chair. When you sit on the chair, just assume when you are sitting on the chair, you are not a point load, you are a UDL. You are a UDL and you occupy particular width of the chair. Let us say that width is X. Then load intensity will be W by X, and this is the case of UDL. This is the case of UDL. No doubt, if you are sitting symmetrically, this will also be W by 2, this will also be W by 2, because symmetry says you will be actually having equal reactions. So the student who could visualize this concept, that I am not a point load, sir, I am a UDL because I am occupying the chair. The student who could visualize it will be in better position, to score high in this interview, who could visualize that it is a UDL, it is not a point load. Now let me take you further. If I have assumed, now you can make assumptions. You can say, sir, let us say X is L by 3 and it is, I am sitting L by 3 distance from each of the supports. I am sitting at L by 3, this is A, this is B, this is C, this is D. And what is load intensity? This is total load divided by L by 3. So 3W by L is the load intensity from point C to point D. Okay, good. Now what kind of shear force diagram you will get it? What kind of shear force diagram will you get it? Okay, let's draw the shear force diagram now. So I take a section here. Distance X from this. What kind of Fx will you get? One is RA. RA is nothing but W by 2. So this will be W by 2 minus load intensity X minus L by 3. Let me write with different color so that it is visible to you. So what is load at distance X? This is W by 2 as per our sign convention positive minus, now this is small w into X minus L by 3. Okay. Now value of X varies from, let us say as of now, till the value of X is 0 to L by 3. From 0 to L by 3, so if I give you X value is 0 to L by 3, 0 to L by 3, it is less than this. So F at point A is W by 2, F at point C is also W by 2. That means this is the diagram which I am going to get. At this value is, nothing but W by 2. This is shear force diagram I am making. Similarly, as per this sign convention, load, this diagram will be like this. Again, this is W by 2 because this reaction is also W by 2. So if I take section from this W by 2, this will like this, shear force diagram. Okay, now as I increase the value of x, now it's a linear, as the x value keeps on increasing, now load keeps on decreasing. At x is equal to, at the center, if you go at the center, let's say L by 3 plus L by 6, just put x is equal to L by 3 plus L by 6. I take at the center, what is the load? Let's see, what is the load at center? L by 2, what will be the load? W by 2 minus small w, x is what? L by 3, so this is L by 6. And what is small w? 3w by L. This is 3w by L. So L by 6, 3w L by L, this entire thing comes out to be 0. So at the center load is 0 and now you have to connect it. This is SFD. Shear force diagram will be like this. I hope this is clear to us. So for L by 3, this is L by 3, this is also L by 3, and for this L by 3 section you get this kind of diagram. This is the SFD for this particular case. Now without calculating anything about BMD, can you guess what is the BMD? Because you need to take the clues. You need to take the clues and you need to find out what will be the bending moment diagram. Can you tell me what will be the maximum bending moment and where will be the maximum bending moment? Slope of BMD is a shear force. Slope of BMD is shear force. What is shear force at this point? Shear force at this point is 0. So if shear force is 0, slope is 0, and if slope of BMD is 0, bending moment is maximum. That means at this point bending moment will be maximum, and he is asking you what is the maximum bending moment. So you will get maximum bending moment at this point. And I told you the area of SFD between 2 points gives you bending moment. So let us say maximum bending moment minus bending moment at A, which is actually 0 in simple sport, is this particular area. And what is that area? W by 2 into L by 3 plus, this is W by 2 into L by 3 plus, this height is again triangle, half of W by 2, this is W by 2 into L by 6. So if you calculate it, you get maximum bending moment at this particular point. And what kind of diagram we are going to get? What kind of diagram you are going to get? Here W by 2 into L by 3. So you are going to get like this, you are going to get like this, and here again and like this. This is the BMD, and maximum bending moment will be like this. Maximum bending moment at the center where slope of BMD will be 0, and if shear force is rectangular, bending moment is triangular. If shear force is triangular, bending moment is parabolic. So if you make this kind of diagram, you must have heard that they will ask you to go on the board and drive something and make some kind of answer. This question was given, draw the shear force and tell where will be the maximum bending moment, what will be the maximum bending moment. Find out what will be the maximum bending moment. And now how do you know some body will fail, where it will fail? So if you put maximum bending moment in the bending equation, you can calculate maximum bending stress also. Hope you got this idea, and this was a single question asked, and through that he's keep on increasing the depth of the question. That is what typical BARC is all about. So many students say that, sir, BARC intro is one of the hardest nut to crack. So how to crack that nut and how to find out what will be the value of bending moment and all. So from the interviews of the BARC, how to crack that, you need to know that they are not asking for your knowledge, they are asking for your approach, and approach is something which is important. You should find it. Yeah, so there are so many such questions. Keep watching all the such questions which are uploaded on the panel by Yourpedia of different subjects. Different mentors of different subjects are putting such videos on Yourpedia channel, and you can revise well what kind of questions in BRC interview will be asked, and there is nothing in this particular topic which you have not studied. So it is not that different books you have to read or something, but you should have practice of these kind of questions. I mean, the questions are asked and you are in position to think. So whenever some question is asked, think innovative, think creative. You need to be calm, you need to be confident, you need to be creative. For BARC interview, these 3 C are required: calmness, creative and confidence, and these come with the practice. Hope you understood the point, and keep watching all such videos. Thank you.